So today we're going to talk about disciplinary vocabulary within math. We know that sometimes if we talk too generally about literacy, it can be hard to see how to apply it within our own classroom. So as I go through some math examples at the secondary level today, hopefully that allows us to be able to see more specifically how it can work with the students that we have in front of us today. So you've probably seen this slide before. And the point of this slide is to help us remember that when we talk about improving reading within our schools, there's really two plans happening. What are we doing with kids that are in our secondary levels that are still struggling to read, and how do we help them learn to read? But then on the right side, there's kids that are already reading at grade level. What are we doing to help those kids, first of all, stay at grade level, but secondly, how do we help them learn to read within the specific disciplines? So it's this right side of this slide that is really talking about what disciplinary literacy is. And we still have to continue within those subjects to be able to help our students read to learn. Now, when we talk about teaching reading in math as a disciplinary literacy, I just hope that this doesn't come across as you have to stop teaching math and then teach some literacy for a few minutes within your math class. That's not the purpose of this. We want to shift our thinking about how do we do literacy in math to what is the literacy of math, and then how do we teach kids to recognize what that literacy is and then use it to improve their understanding. So we're not teaching reading using the subject. We're teaching the subject using the language of that subject. We want them to be able to speak it. We want them to be able to write it. We want them to be able to both read it and understand it when they hear it. So why is it important to focus on disciplinary vocabulary within math? Just like we said in the last slide, we want our students to be able to understand, speak, and write the literacy of math. We know that math is a language in itself, and so as we help students understand the words of that language, then they are able to better communicate within that language. As they build their vocabulary within math, it will actually build their retention as well. Students are more likely to retain that vocabulary and then start using those words as they enter into being an adult. Root words, the earlier that we teach them, the more likely it is that they'll understand them and use them as they become older, and they'll become part of their everyday language. As we focus on vocabulary, it will help them prepare better for tests and be more ready for those. Yeah, students, sometimes they feel like they have to all of a sudden get ready for something like a diploma where we have to get lots of words in front of them, when if we can focus on those words throughout all of the secondary level, we can be able to help students become more familiar with those words, start using those words, and then it's not such a rush before a big test is put in front of them. The everyday, everywhere, the more kids understand vocabulary, the more they'll be able to interact just in their everyday life and in places where words are starting to come out and be used a lot more in their environment. And lastly, the more we can help students with their vocabulary, the better prepared they are for entering post-secondary. It will help them as they are writing. It will help them as they are reading the papers that are put in front of them, as they have to understand all of the tasks that are asked of them within their math classes as they go into post-secondary as well. So let's look at a specific math example right now. Here's a question that I actually pulled off of one of the released questions from the diploma that students were asked to answer. And when you look at this question is actually loaded with math vocabulary that students need to be able to understand in order to answer this question. And they have to be able to differentiate between meanings of words so that the words are very specific to them, and being able to understand exactly what's being asked of them. And when you look through this question, there's vocabulary in there like vertical, horizontal, axis, translate, transformations, notation. And they need, even when you look a little bit closer, the word about here is definitely used in a math way. And so when it's about the y-axis, how does that change it compared to when that word is used differently within other subjects? And so as you dig in to look at all of these vocabulary words, Can a student use them? Can they use them accurately? And can they use them all at the same time to understand what's being asked about? So they need multiple exposures to all of these words so that they can be able to successfully work through these questions that are being asked of them. When you look down at the bottom of this example, there's the word respectively in the numerical response question there. There was a question on a test a few years ago where the word respectively was used in option D of a multiple choice, but not in option C. And other than that, the options were identical to choose from for students. And there were a couple of students that actually did not know the difference between what C meant and what D meant in order to make their choice on the test. And so it made it that much harder for them because they didn't know the word that was there. So besides the general needing to learn new vocabulary, which happens in every subject, here are some difficulties that belong only to math, demands of the text within math that are placed on students. The first part that we'll talk about is that each word must be understood specifically in service to that particular meaning. So words that can be interchanged in other texts may have different meanings in math texts. Now the example at the bottom of this slide is radical. The word radical in math has a very different meaning than what the word radical in social studies would mean. And sometimes our students actually need this differentiated for us so that they can see that there's a difference between the subject languages and how to use words. And then as they go through and see those differences, they can realize that the way it's used in one subject cannot be applied to the other subject. Most of the time we actually want cross-subject application, but if that application will cause confusion, we need to be able to separate that for our students. Now, the other demand of a math text that's specific to vocabulary is that math reading requires a precision of meaning, and each word must be understood specifically in service to that particular meaning. So in math, the word the has a different meaning than the word a. Like if we're saying find the solution versus find a solution, there's a difference in meaning there of how many solutions there are. Even how the small word of can tie to what a student should be doing. Should they be multiplying in their question? Or what's the actual question asking of them? And so there's an exactness of language in math that actually makes the vocabulary of math almost more important because the context is harder to figure out in math at times. And so we have to be able to help students see even those little words. And so as we move forward with the rest of this slideshow, there'll be some things in this slideshow that we'll talk about how do we work with vocabulary within math so that we can help our students be able to get past these demands that math puts on them beyond what other subjects do. As we look at this slide about what does a skilled reader do within their ability to understand words, there's a few things that really can jump out here, even within math. I'm going to not read right through this, but there's a few points I just want to point out. One, a skilled reader knows the importance of learning new words. So when there's a new word put in front of them, they don't just brush over it and assume that it's okay that they don't understand it. They dig in and they want to know what that word means so that if it comes up again later, then they'll be able to understand it. And they do understand that words can have several meanings. And so this kind of relates to that last slide where we talked about the different classes having different meanings. Skilled readers will know that, and they'll be able to hold ambiguity in their mind if they need to, while they test meanings of words if they only know a different subject's meaning of a word. And so that way they can check it. If it doesn't seem to be making sense, then they can go back and realize that there can be a different meaning. Jumping towards the bottom, skilled readers use strategies to figure out an unknown word. So they don't just skip it, they try things to see what they can do to be able to figure it out. The first one is they're breaking difficult or long words into parts, the prefixes, suffixes, root words, and then they can look at those to see, does that help me understand? Connected to that is the second subpoint under there is the idea of how words relate, especially this one, the idea of transfer, translate, transformation, all those things. How do those words connect to each other, and can they use that information to be able to understand that word? Now I'm going to show a video here and then get into more of the strategies, but I just want to point out here that this slideshow specifically is about vocabulary strategies. Now, some students may be missing vocabulary and we need to put vocabulary strategies in place to help them, but sometimes they need more than vocabulary strategies. By teaching a vocabulary strategy, it doesn't necessarily solve a problem of a student who doesn't read widely. If we can get a student to read more and read more widely of what they read, we'll be able to build their vocabulary, and that would be huge, and that would actually help solve a lot of problems. But if there's a specific vocabulary lacking skill for students, these are the strategies that we'll want to do in order to help them. Now, before that, on the next slide, I actually just want to show a video that kind of connects. It's not a specific math video, but it's just a video that shows how much exactness of language can matter.
Hello? Hello?
911, what's the nature of your emergency?
Mein Automobil ist on Fritz.
Your automobile's on the fritz?
Ja, yes! Mein Automobil ist on the Fritz.
That's not really an emergency now, is it, sir?
Nein, mein Automobil ist on the Fritz.
Alright, don't call back here again.
Hallo? Einen Moment, Fritz, bitte. Hallo? Hello?
So as we move forward now, I'll be dividing this into a few sections, but the first section is, what do I want my students to be able to do? We want our students to be able to understand new words, and what strategies can we use to help them learn new words. And when a student is reading on their own without us next to them, we want them to be able to attack those new words on their own. So what does that mean? I, as the teacher, need to be able to do? I need to know the strategies to teach those new words, and I need to know what skills to teach them so that when they're on their own, they can attack the word and figure those out. So we'll move through those sections first here. So the first strategy for how we teach new words to students is the Freyer model. Now, we've probably seen this a lot before and just didn't know that that's what it was called. But this is actually probably the strongest research-supported vocabulary strategy that there is, as there's an important term that we want students to know. If we can work them through these 4 sections of the Freyer model, then it will really drive home their learning as they are introduced to this term. But then as they are repeatedly exposed to that term over a few weeks, as long as we go back and connect them back to the Freyer model and make sure that everything in the Freyer model is still up to date and correct, then that will drive home all of their experiences and be able to help them gain a deep understanding of a new term. As you help students write their definition in their own words about whatever the concept is, what are the facts and characteristics of that, and examples. Those are the 3 easiest ones. The non-examples is often hard. If we're not careful here, the kids will go out into left field real fast to give us non-examples. It would almost be better if it was called common mistakes. Now, this is one that we sometimes see. Some of the Freyer models online will actually take this non-example out and put in a different section. But this non-example section is really important for students to see where's the boundary of a concept where it's something no longer fits in with that concept. We'll show some examples as we go through this. But again, this is probably the strongest research-supported strategy that's out there. And I've seen some people connect this with word walls where they actually put their Freyer models up on the wall as their word wall too. Now here's a math example using the word equation. Now as you work students through these sections within the Freyer model, the order actually doesn't really matter. You could write examples, and then looking at the examples, you could come up with the definition together or come up with facts or characteristics that you see from those examples. Or you could go through the characteristics and facts and the definition first, and then from that create examples together as a class. That order can go either way, and then make sure that you don't skip the non-examples part to be able to show what doesn't fit into those facts or into those definitions to show where it doesn't work anymore. One of the best examples I've seen too, and again, I'm going to go back to that radical example that we talked about earlier. Part of the non-example, it really does help to include the non-math definition. So what is the social studies definition of that word? And put that in the non-example within your math class so that they can see the separation from those subjects within the meaning of that word. Now the next 3 slides through here, they're just YouTube clips actually that we've gone through and chosen some that are very good at explaining a Freyer model, how to use it, but also walking through some high-level math examples. I believe the third one is about functions and what a Freyer model could look like to help students understand what a function is.
If you're looking for a simple center activity that can help your students increase their vocabulary, consider adding the Freyer model to your instructional toolkit. The Freyer model allows students to develop a thorough understanding of new words. Here's how it works. The model is made up of 5 sections. The center of the graphic organizer is reserved for the vocabulary word. So for this example, let's use the word polygon. Now let's fill in the example section of the graphic. Now that we've listed a few examples of a polygon, we'll write down some non-examples. The list of non-examples allows you to gauge your students' depth of understanding. The third section is reserved for facts or characteristics. Finally, we can write a definition. So, a polygon is a closed plane figure with 3 or more sides. Now, there are many other ways we can use a Freyer model, or at least a graphic that looks similar. For example, instead of placing a vocabulary word in the center, we can write a number. Let's use the number 36. Now, the only section that I think should be changed is non-examples. I'll change it to factors. Now, we can say that 36 is even, composite, and rounds to 40. The factors are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Examples of 36 are 9 times 4, 18 plus 18, and 4 times 5 plus 16. Finally, we can define the number 36 as an even composite number with 9 factors. So if you're looking for a simple yet meaningful center activity, consider tapping into the power of the Freyer model and using it with your students. See you later.
Okay, so Freyer models will usually be your bell ringer. Usually what I will do is I will have one of these up and it will already have the word in it. And then your responsibility will be to fill in the other 4 boxes. So our word today is rational number. So you always put the vocabulary word in the center box. Sometimes I will be nice and I will give you the page number that you can find the definition on. This one is going to be page G27. And that is the glossary in the back. So in definition, you would write any number that can be expressed as a ratio of 2 integers. So one fact would be that they involve fractions. You could put or can be written like a fraction. So one example is 6/1. And this is the same thing, guys, as just a whole number 6. So that's why we say that whole numbers are also rational numbers, because I can take any whole number and I can write it like a fraction. What's another example? So 5/8. Can that number be classified as anything but a rational number? Can 5/8 be a whole number? No. Can 5/8 be an integer? No. If it's a true fraction, small number on top, big number on bottom, absolutely positively every time only a rational number. Somebody give me an example of a rational number that is also an integer, but it can't be a whole number. You got one? No, that wouldn't be an integer. -9. Guys, because I can take -9 and I can make it into a fraction. So keep that in mind, because -3/4 is also a rational number, and that's it. It is only a rational number. I know we see that negative and it throws us, and when we want to say integer only, we've got to get that out of our heads. If you see a fraction, a true fraction, small on top, big on bottom, then it can only be a rational number. Okay, non-examples are hard on this one, because the only thing that's not going to fall into the rational category is an irrational number. And we haven't studied that. So I'm just going to give you an example. So an example of that would be like the square root of 2. That's tough, because y'all haven't gotten to irrational numbers. And that's a whole new can of worms to open up. So this is how I expect Freyers done. We will put them in our journal. But when you come in from now on, I'll have a blank one with just a vocabulary word in here. And I need you guys to fill this in. And then we will do one together where you can check, but I will be asking y'all for the answers.
All right, this is for Algebra 1. We're talking about functions and what a function is. So on your paper, would you make sure you go ahead and write functions? And we're going to look at the definition. A definition of a function is a relation where every input has exactly one output. And you've seen function tables with the machines that have like a number going in, something's happening here, and the number's coming out. So you have like a little robot, and it might say, you know, a 4 is going in, something's happening, and you're getting an 8 out. 6 is going in, something's happening, and you're getting a 12 out. Well, it might tell you to times 2. So you've seen these function machines, kind of cute and fun, but we're going to really dive more into it. So the definition of a function is relation where every input has exactly one output. So we're going to look at different ones. Right now that might seem a little vague, but we're going to look at different examples. So for a table, we're going to use an input-output table. And our input-output table in math, in Algebra 1 and beyond, you're probably going to use X and Y a lot more. Because it'll be graphing onto a coordinate plane. So here's an example of a function table. So you have, now these numbers, I'm just making up some numbers for X, and then I'm just going to make up numbers for Y. Don't feel like you have to find the rule yet from -2 to like input this number to this number. So I'm just going to make up some numbers. But what I'm doing is I'm making sure that every input has exactly one output. If -2 goes into a machine, something happens to it and comes out 7. -1 goes into a machine, something happens, comes out 12. 0 goes in, it's 19. 1 goes in, 22 comes out. 2 goes in, 27 comes out. That is an example of a function. Every input has exactly one output. Now a non-example in table format would be something like this. If we had -2 went in as 7, -1 went in as 12. Well, that's okay right now. 0, 19. But let's say -1, instead of -1 going in and getting 12, -1 comes out and gets in the 20, it goes in, but 22 comes out. That is not a function because the -1, same input, but two different outputs. So that is what making it not a function. If -2 goes in, we should get 7, but if it comes out 27, nope, it's not a function. You do not want your x values to repeat. So can't have the same input produce two different outputs. So you don't want the same input. These are your input numbers and these are output numbers. Think about science too. These are also known as your independent variable and your dependent variable. Okay, so you can't have the same input produce two different outputs. So for an example here though, here's another example that can be a function. What happens if you have -2, 2, 0, let's say 2, 2, 2. You can have the y values repeat. So the outputs can repeat. Output can repeat. The inputs you do not want to repeat. Okay, so there's a table format. All right, so let's look at the mapping. And in fact, down here, I'm going to have you split that up. And I'm going to have you also put ordered pairs down here. Now, a mapping. A mapping is very similar to a table, but it looks like this. So here's an example. So example would be like 1, 2, 3. And this 1 is being paired to 4. This 2 is being paired to 5. This 3 is being paired to 6. Don't worry about the rule right now. We're just identifying functions. Every input went to exactly one output. Okay, here's a non-example. If 1 goes to 4 and 5, and 2 goes to 6. Right here, this is saying that 1 is going to 4 and 5. Well, that's not possible for a function. You can't put in 1, do something to it, and get a 4 and do it again, and then get a 5. So that's an example of not a function. Ordered pairs. So the ordered pairs, now we're going to do the braces, and we're going to do a set of ordered pairs. So like 1, 2, 3, 4, 5, 6. This is an example. That's fine. Every input, the x value has exactly one output. The 1's going in and getting 2. The 3's going in and getting 4. The 5's going in and getting 6. But here's a non-example. That's a non-example. Whoops, that's a bad one. 1, 2, 3, 4, 1, 6. Right here is the non-example. You cannot get 1 in and get 2, but then put in 1 in again and get 6. You don't want your x values to repeat, your input values. If they do repeat, they have to go to the same output, which is kind of ridiculous. You're plotting the same point twice. But that's what's happening here. So an ordered pair, mapping, tables. Now we're going to look at graphs. Every input has exactly one output. So in here, if we plotted any of these points that were examples, like 1, 2, 3, 4. So this can be a function. This can be a function. So the horizontal line can be a function. We can have it going down. These are all examples of functions. Now this graph didn't come out very well, but you're going to be able to see it. Here's a non-example. So this is non-example. Here's a non-example. A vertical line. A vertical line cannot be a function because how's this being made? It's being made by repeating the x value over and over again. This is maybe like -3, 0, -3, 1, -3, 2, -3, -3. This x's are repeating over and over. Here's another one that's not a function. Oh, excuse me. That's wrong. Erase that. Erase that. I was going the wrong way. That is a function. It's just not linear. This is not a function. Oh, dang it. There's my lights again. So that's not a function. All right, lights, come on. This is not a function because this is why. This x here and this x, these 2 points have the same x. And we can do a little test called the vertical line test. If you draw a line going vertically down, whatever you're trying to test, if it's a function, if it hits more than 1 point, it's not a function. If you draw a line straight down and it hits more than 1 point, it's not a function. If I draw a line from straight down this one, I only hit this point. This line here represents a function. So vertical line test means if you draw a line straight down and you hit more than 1 point, it's not a function. If you hit just that point on that line, it's a function. Okay, so you're going to be doing some work about identifying functions first. Make sure you have all these notes ready for our workday tomorrow. Thank you.
Okay, the next major strategy for helping students learn new words is to use word walls. These have actually, unfortunately, gotten kind of an elementary spin put to them over the years, but there's actually lots of research, even at the secondary level, that shows how important these word walls are. Like, the purpose of a word wall is to actually keep the language of your subject alive. So sometimes as a teacher, I was really good at taking a complex subject or complex language within the subject that I taught, and I could simplify it down quite well so that a student could understand it in simple terms. But I wasn't always the best at then getting the student to turn around and start using the language that I had simplified from. So I was bringing the complexity down, but I wasn't bringing the students' learning and complexity of that literacy of the subject back up. And we want the students to use that language as much as they can. Part of that is when a student is either reading or listening, the word wall actually helps them be prepared to understand that word when they come across it. And it actually also shows the students what words we as the teacher find important. And so it will help them narrow in on what words they really need to learn. But when they're writing or when they're speaking, which is a very connected to reading process, if they're writing in math, they can show that they understand a concept. And if they're explaining a concept but not using the word that's on the word wall, you'd want to send them back and say, okay, now make some corrections, but now I want you to say these words using some of the words on the word wall. And when they're speaking, if they're giving a simplified answer that is correct, have them restate it or get another student to restate it and say, but now I want you to use 2 words from the word wall, and get them to start using the language of the subject so that they can be able to both express themselves and be able to understand that language. Now, one of the keys for word walls is don't let it get too big. Even the example on the right might have too many words there. You don't usually want to get beyond 7 to 9 words at a time, which means you have to choose which words are most important to be able to put in front of students and help them see them often. And it's okay if once you're getting to around that level, if you need to add a new word, if you're taking one of the old ones off, and just keep that word wall alive and moving. This shouldn't be a laminated chart or poster that goes on your wall where the words don't change. You want to be able to post them while they're looking at you, post them and say this word is important, and then you refer back to it several times. And then eventually it comes down as it becomes one of the older words up there, and you see that your students have mastered a word that really matters to them. I've even seen some teachers take the words off the wall and then do an activity on the ground. The next 2 slides here again are also YouTube clips that show word walls being used. And the second one in here does show a teacher who's taking the words off the wall and is just doing an activity using those words on the carpet in the classroom. So take a look at those and then we'll move on again.
While word walls are a common sight in elementary classrooms, word walls also reinforce vocabulary in secondary classes. When done well, word walls become an interactive visual resource to build higher levels of conceptual understanding. A word wall is a display area for high-frequency vocabulary words. Start by identifying a space that can be consistently used throughout the year. The word wall format is not limited to alphabetical listing commonly used in elementary classrooms. Often, secondary courses benefit from organizing content-related words by meaning. In this picture, the teacher sorted the math vocabulary by course and color-coded the terms by unit. Next, identify key words that are used frequently in the content area. Add 5 to 7 new words a week as they relate to the unit. Remove words as needed to prevent overcrowding. Some high-frequency words may remain all year. Integrate word wall activities as part of the classroom routine. For example, at the beginning of a unit, have students sort keywords into groups like words I don't know, words I've heard of, and words I know and can explain to others. Have students revisit this sorting activity throughout the unit. Students can also use the words to form relational diagrams, like a Venn diagram to compare and contrast terms, a concept web to describe new vocabulary, a linear array to show degrees of meaning, and a morphological tree to analyze word parts. Students can also take one term and create a concept map, or draw a picture to develop a deeper understanding. For review activities, students can make a crossword puzzle or play the password game. Another activity to visually grasp the frequency of certain vocabulary words is to use Wordle. Students paste a segment of text on this site and view the resulting graphic. The size of the word depends on its level of frequency within the passage. Word walls work for any content area or grade level. Select relevant, meaningful vocabulary terms and routinely refer to the display space during instruction. Living word walls become an integral reference for students to view, use, and acquire new vocabulary.
So today we use the interactive word wall as a concept map. When students enter the room, the vocabulary words and phrases are already spread out on the floor. First thing I want you to do is identify some vocab words and phrases that you know you can make connections with other words. When a student comes to the middle of the interactive word wall, they are connecting their vocab word or phrase to a previous vocabulary word or phrase using the arrows. And when they place their words, they need to explain the connection that they see or understand. The purpose of an interactive word wall is to have students grapple with vocabulary that they're working on in class in an engaging and hands-on way. They're really illustrating the connection with those arrows. Some connections that students are able to make regularly would be cause and effect relationships. Veterans made sacrifices, therefore we honor them when they come home. It helps students literally see the connections between words. Students are able to build upon each other's ideas. They are using vocabulary words in context. And it's a great way to scaffold to the writing process and prepare students to write using these vocabulary words. This allows them to synthesize all these concepts and all these vocab terms in ways that helps them put it all together.
So those were the two main ways that we want to make sure are happening in order to help our students learn new words. Now, the other thing that we want our students to be able to do is to be able to attack words when they're on their own. Using morphology or word parts is probably the best way for students to be able to do this. The ways to do this are simple, and to be honest, it's something that most of us are probably already doing anyways. It's just to make them aware of what you're doing and to even make your strategy explicit to them so that they know what you're doing. First of all, you just want to help students be aware of the word parts. So be able to pull it apart into prefixes, root words, suffixes, and to be able to help them understand what each of those mean. And then you want to work together through the meaning of each part of that word and then show how the word comes together for the meaning that it has. Now, point out any word that uses a prefix that they've already learned, or a root or a suffix, and that way they can get the repeated exposure over and over as they are getting used to looking at words in this way. And then you want to include a broken up word back on the word wall within the Freyer model so that they can see how you're breaking it up as you're modeling that for them. And so it just gets it so it's natural for the student to be able to look at a word in that way and to be able to pull it apart. Now, the last thing really to say about morphology is don't give the lists of prefixes and suffixes, like don't print one off and give it to the students. I have put links here that go to lists like that, but these links are really just for you so that as you look, you can see it and to be able to look at what some of the prefixes and suffixes and root words mean so that you are more aware of them so that as you teach them, then it can help. I know that a lot of these are probably common to you and you know most of them already. Occasionally there is a new one that we haven't seen before. And so even just skimming through this list can help us know how to point that out. There's two ways that students can attack words on their own. One is using morphology and the other is reading within context. Now, math doesn't usually give a lot of context as to how do you figure out what a word means when it's already within a paragraph, but math doesn't usually set it up that way. So I'm actually not going to cover the context part because I'm not sure that it fits within math. But if you are interested in that, I would take a look at the science video and try to just jump to that section so that you can see how it fits within that if you believe that context does matter within math and you'd like to see that part of it too. So the last section here today, beyond what I want my students to be able to do, what do I as a teacher need to be able to do, is the section about what do I as a teacher need to know. The first thing is it's important to be able to be careful in what vocabulary we choose to teach. So students actually learn around 3,000 new words per year while they're in K-12. There's no way that we can teach all of that. There's just too many. Our curriculum and the textbooks, they just have way too many words in it. Would have to be vocabulary teachers all year long. And while learning words really matters, we don't want to spend all of our time just going over new words. So the key to this is for each unit, we need to choose the words that students really need a depth of understanding around. And then we apply these strategies that we've been talking about to these terms. If there's a new word that students are going to struggle with in a text, but it's not really vital to understanding the curriculum and the outcomes that we're asked to teach in Alberta, then we just tell them what it means. We don't need to get into long explanations and digging into every single word that we come across. We just tell them so that it won't get in the way of understanding the text that they're reading, and then we can just move on. The other thing to keep in mind when you're choosing your vocabulary is the different tiers of vocabulary, tier 1, 2, and 3. Now, let's not confuse this too much with anything within RTI or collaborative response model. It's just a different triangle. But when you look at the tiers of vocabulary, tier 3 is our very subject-specific words that we use. And tier 2 is high-frequency words that we use commonly in academic language, but they're not your everyday words. Sometimes these tier 2 words are the ones that can catch kids, but we don't choose them as words to teach, and we need to not forget about those, especially words that are going to wind up in our assessments quite often, like summarize or analyze, words like that, and exactly what they mean. So as you are choosing your words, make sure you're thinking about, is there any of those words that you need to get in there to include for students? Another thing we want to know as teachers is when we're looking at introducing words to students, we want those words to come from context, not us just introducing a word at a time. We want the student to come across the word, and then as they are trying to figure out what those words mean, or as you're introducing it before they're reading a text, we help them understand that word because they're about to use it. We don't want to come up with lists of words and give them to students to introduce those words. Providing lists can help as a review. We don't want that to be the way that we introduce the words to the students. And then once they are seeing those words in context, we want them to have around 8 to 12 meaningful interactions with those vital words. And then that can drive that deep understanding of what that word or term means. And lastly, we want to help students develop some word consciousness. We want them to want to know what the words mean and then why those words were chosen by the authors. And so as you're looking at your math questions, as you're looking at even the preamble before a math question, if there's a word in there, you want to help the students figure out what that word means, but then figure out why do you think that this was the word that was used here instead of maybe another word that might be similar. The last part of the what do I need to know as a teacher section is just keep the lessons fast-paced. Like, we don't want vocabulary to take over a lesson. We don't want to shut down teaching math to teach vocabulary. It should be a natural, normal part of a lesson. As a word comes up, you help them understand it before they read something or before they get into the questions that include those vocabulary. Help them go over it and then just keep it short within a few minutes and move on so that it doesn't become this overbearing, over-focused thing that the students begin to hate and we feel like it takes too much time. Now, talking about vocabulary and helping do these strategies, I just want to end here with how do these fit back into the tier 1 strategies that we've talked about before. And so when we look at them, how does it fit in with fluency? As we hear how new words sound and what they mean, it really helps a student be able to know how to use that word in their language later. When we talk about providing accessible text or accessible learning, as we read at our own levels, students are able to read new words on their own and then they incorporate those into their own vocabulary, and that increases their ability to use language. And as we pre-teach vocabulary, it actually allows students to stretch into higher levels of text that they might not have been able to do before. When we talk about access to daily reading, so independent reading is actually what increases vocabulary development. When we talk about writing, it gives them opportunities to use it. When we look at building background knowledge before reading, that might be what a student needs in order to understand a new word. And then as we speak with others, it allows a student to both hear new words and use new words. And then the time is what allows us to do all of these things. And I know that's a really simplistic way to look at it, but as we take these tier 1 strategies and put them into place, we need to remember that this can take a school that has 25% of their students as struggling readers and reduce it to 6% if we are just doing these things, because as we do these, we will naturally have time to do these vocabulary strategies that we've talked about today, but it will also allow us to do some of the other strategies in some of the other upcoming slideshows that we'll talk about at another time. Now, my final thought is the importance of putting text in front of students every day. So as students, they need to read a lot and they need to listen to others speak so that they can practice their new skills and so they can learn new words. The more text we put in front of them, the more time they are spending. Time is a big thing, just an infographic, but it shows the impact of adding a few minutes a day has to the amount of reading and reading development that they get, even within discipline literacy. And while today I went over a few really common research-supported strategies for vocabulary, as you look around and do your own research for vocabulary strategies, you'll notice you'll be able to find a lot of other things that are saying similar things or activities that are very similar. I've put a few links here, like Marzano's steps to teaching vocabulary. There's a WordWalls document in here. They all are kind of working towards that same purpose. And so as long as we're looking towards how do we actually teach words to these kids as they're trying to develop their vocabulary, then we're doing good things. I just wanted to include the most basic ones here that really have a lot of research behind them. I'm not going to say any more about that Kitty and Gallagher slide next. Take a look at it to see, is there any way that as you increase a few minutes within your class of putting text in front of kids, will that help kids develop and use the words that you're wanting them to use? Next is a picture I actually took from Penny Kittle's slideshow when she was down in Lethbridge. And I wanted to show exactly the demands that are coming up on these kids. This is the demands that happen on a student in their first year of post-secondary and what's expected of them. And as we do things like put more text in front of them often, what will happen is we will also not just be building their skills, we'll be building their stamina. A lot of times it's not necessarily a reading struggle that they have, but it might just be a focus struggle. And as we put text in front of kids more often, we will be able to build their stamina so that they can handle more text as they try to work through and understand what's being put in front of them. And the last slide today is a video. You might have seen this one before too. It's of Tom Brady and the practice and time that he puts in to master the skill that he does in his profession. So as we look at kids and teaching them skills to read and teaching them skills to read within math, we may have to put text in front of them so that they have lots and lots of practice so that they can master these skills too as they master the use of language within math.
Every single day. Every single day. Every single day. Every single day. No matter what.